Hello and welcome back. This is another Algebra 1 video where today's focus is going to be on equivalent equations. Okay, here is our first example we're going to do together. As you can see on the left, we have some choices as far as what equations would be equivalent to 8 equals g minus -2. So I think the first thing we should do is we should probably simplify our original equation, this one right here, to make it a little bit easier to spot when some of the other equations may be equivalent. So let's go ahead and do that. When we have a minus of a negative, a lot of times that turns into a positive, right? To subtract a negative is the same as adding a positive. So I'm going to rewrite this as 8 equals g plus 2. Now that might make it a little bit easier for us to figure out which of these equations might be equivalent. Let's start with the first one. First one is -30 times 8 equals -30g minus 60. Okay, so let's start by actually calculating -30 times 8. That would be -240. And if you're curious how I did that in my head, you can check out some of my previous videos about multiplying and dividing numbers that end in zeros. Okay, so that's going to be equals -30g minus 60. So what I might want to do now is try to look for a factor that all three of those terms have in common. They all end with 0, so I can definitely go ahead and divide them all by 10. In fact, that's where I think I'll start. So I'm going to start by dividing this by 10, this by 10, and this by 10. So you can do this as long as you do it to every single term in the equation. So this is going to be -24 equals -3g and then minus 6. 240 divided by 10 is 24, -30 divided by 10 is -3, and -60 divided by 10 is -6. So now I notice that 24, 3, and 6 all have 3 in common. So I'm going to keep going. I'm going to keep dividing all three terms by 3. What that gives me is -8 over here equals -g minus 2. Okay, so I'm pretty close to having it fully simplified. The only thing I noticed is that all three terms are negative. So I could continue to simplify it if I divide everything by -1. -8 divided by -1 is 8 equals -g divided by -1 is just g. And then -2 divided by -1 is +2. So to represent the positive, I put a plus there. So when I fully simplified that equation, I ended up with the same equation as our original one, 8 equals g plus 2. So I'm going to say that yes, this equation is equivalent. Okay, now I'm going to delete a lot of this work here so I can look at the next choice. Now, I don't have to fully simplify. I just have to do enough to figure out whether it's equivalent or not. So the next choice is 6 times 8 equals 6g minus -18. So I'm going to go ahead and simplify that. 6 times 8 to 48 equals 6g. And when I have a minus a negative, again, just like at the one at the top, I'm going to change that to a plus and make it 18. Okay, so now I'm going to go ahead and see if I have a common factor I can use for all three of these. And I think I do. I think all three of those terms can be divided by 6. So I'm going to go ahead and divide this by 6, this by 6, and this by 6. 48 divided by 6 is 8 equals 6 divided by 6 is 1, and 1g is just g, plus 18 divided by 6 is 3. So this one was really close. It's just that 18 divided by 6 is actually 3, not 2. So this one is not equivalent. Okay, let's look at the next one. And again, I only have to simplify it enough for me to be able to tell whether it's equivalent or not. So the next one is 50, oops, writing with the wrong tool. There we go. 56 equals g plus 2 times 7. Now I realize that this is in parentheses, but there's no number outside of it. So I can just go ahead and kind of get rid of it. But if you want me to, I can do the distribution. So we can just double check. So times 7 would be here and here. So this is 56 equals 7g plus 14. Okay, I think that all of three of those terms can be divided by 7. Yep, I think so. So I'm going to divide this by 7, this by 7, and this by 7. 56 divided by 7 is 8. 7 divided by 7 is 1, or just G. And then 14 divided by 7 is 2. So it looks like I end up with the same equation that I started with. So I'm going to go ahead and circle that one. Okay, let's look at that last one to see if it is equivalent to our original equation. Negative 32 times 8 equals negative 32G minus 96. Okay, so those are some big numbers. I'm going to go ahead and calculate what 32 or negative 32 times 8 is, and that's negative 256 equals negative 32G minus 96. Okay, now I'm going to be looking at these to see if I can find a common factor. I know that in the original equation, I have to end up with 1 in front of the G or just G. So I'm going to try this. I'm going to try dividing all the terms by negative 32 to see if that gives me the same equation. That's why I chose that to start with. So negative 32 divided by negative 32 is 1. So that's just G. Negative 96 divided by negative 32. I don't believe that is 2, but I'm going to double check. And nope, it is actually 3. It's positive 3. So now I can stop. I don't even have to do that 256 divided by 32 because I can already tell that this is not going to be an equivalent equation. So I can go ahead and cross that off. All right, so it looks like the choices here would be the first one and the third one. Okay, here's our next example. We want to know which of the equations from the list are equivalent to 11 equals s plus t. So that means I need to kind of simplify and rearrange these just to see if they are equivalent or not. So no simplifying needed for the original equation, 11 equals s plus t. That's pretty much simplified. So let's start with the first one. The first one is 17 equals s plus t plus 6. So I noticed in the original equation that s plus t is by itself on the right and then the other numbers on the left. So let's go ahead and try to get this expression by itself. The way I would do that is to subtract 6 from both sides so that that cancels out to 0. 17 minus 6 is indeed 11, and then I have s plus t left over here. So that is perfect. So that does match the original equation. So I'm going to go ahead and circle that one. Okay, here comes the next one. Let me take all that down. Okay, the next one is 15 equals 4 plus s plus t. Again, I want to isolate that s plus t expression so it's by itself on the right. In order to do that, I have to subtract 4 from both sides. This one will eliminate and I'll end up with 11 again over here. So that does equal 11 equals s plus t. So that is the same as the original equation. All right, let's check out the next one. Go ahead and take this down. Okay, this one is 18 equals s plus t plus 7. Okay, so I'm going to isolate that s plus t expression, and then I'm going to move the 7 to the other side. So minus 7, which again gives us 11 equals s plus t. So that does match the original equation. All right, I'm going to look at the last one just to see if it matches after deleting that. Okay, so we have 19 equals s plus t plus 8. So I'm going to isolate that s plus t expression right here. And then I'm going to move the negative or the 8 to the other side by subtracting it from both sides. And 19 minus 8 is indeed 11. So it looks like all of these choices are equivalent to our original equation. Okay, here is our next example. Which of these equations on the left is equivalent to the equation 5z equals 12? Okay, so 5z equals 12 is pretty much already simplified, so we don't need to do any simplifying there. Let's try the first one. 2 plus 5z equals 14. Okay, so in our original equation, 5z is by itself on the left, so let's make that the case over here. So this is by itself. That means I need to move the 2 to the other side. And since it will cross the equal sign, I have to do the opposite to both sides. So the opposite of a positive 2 is a negative 2. That cancels out, and I end up with 12 over here. So this is 5z equals 12. And this one does match. Awesome. All right, so let's try the next one. Take that one down. Okay, this one is 3 plus 5z equals 15. And again, I want to get that 5z completely by itself on the left. That means I need to move the 3 to the other side of the equation by doing the opposite to both sides. So the opposite of a positive 3 is a negative 3, and a negative 3 over here. That cancels. We bring down the 5z, and that equals 12. So that is the exact same equation that we started with. So B also matches. Or the second one, however you want to look at it. All right, here comes the next one. This one is 6 plus 5z equals 18. Okay, so now we have this. We want to isolate that 5z by itself on the left, which means I need to move the 6 to the other side of the equation across the equal sign. That means I need to do the opposite to both sides. The opposite of a positive 6 is a negative 6. So I'm going to go ahead and subtract those 6's. That leaves me with 5z on the left, and 18 minus 6 equals 12. So we have another equivalent equation. All right, let's try this last one. Okay, this last one is 5z plus 7 equals 20. And again, I want to get that 5z completely by itself. So I need to move that 7 to the other side. And so I have to do the opposite. The opposite of adding 7 is to subtract 7 from both sides. And when I do that, I end up with 5z. Oh, that z could look a little bit. Okay, that's a little crazy. 5z, there we go, equals. But 20 minus 7 is actually 13 instead of 12. So this one is not an equivalent equation. All right, so out of these 3 or 4 choices, the first 3 choices were the ones that were equivalent. Okay, here is our next example. We have the original equation of 11 equals c times d. Okay, so let's start with the first choice. The first choice is 4 equals c times d minus 9. So again, we want to get that c times d expression by itself or isolated. So I'm going to go ahead and put parentheses around that, which means I need to move that negative 9 or that minus 9 to the other side by doing the opposite to both sides. So I'm going to add 9 to both sides to cancel that out. And then 4 plus 9 is 13. So 13 is not what we're looking for. We were looking for 11. So we're going to cross that one off. That is not equivalent. All right, let's look at the next one. Let me delete that. We have 9, oops, writing with the wrong tool again. 9 equals c times d minus 3. Again, I want to isolate this expression of c times d so that it's by itself on the right side. That means I need to do the opposite to the 3 to move it to the other side. So the opposite of subtracting 3 is to add 3 to both sides. Cancel that out, and we get 12. 12 is not what we're looking for. We're looking for 11. So we're going to have to cross that one off. That one is not equivalent either. Okay, let me delete that one. This one is 7 equals c times d minus 4. So again, let's isolate that CD expression, and we need to move that negative 4 or minus 4 to the other side. Since it's going to cross the equal sign, we have to do the opposite to both sides. So we have to add 4 to both sides. These two will cancel. 7 plus 4 is 11 equals c times d. And that is exactly what we're looking for. So this one is an equivalent equation. All right, let's look at that last one. Let me go ahead and delete that. That is 4 equals c times d minus 5. Okay, so again, we need to isolate this expression of CD. That means I need to move that minus 5 to the other side of the equation by doing the opposite to both sides. So I'm going to add 5 to both sides. And that that will cancel out. 4 plus 5 is 9 equals C times D. So that is not what we're looking for. We are looking for 11. So I'm going to go ahead and cancel that out. And that means from our list here, the only equation that is equivalent is the third one, 7 equals CD minus 4. Okay, here is our last example for today's video. Which equations below from the list are equivalent to S minus 8 equals 10? Okay, so we don't have to simplify that unless we want to. But no, we actually can just leave that as it is and just kind of see if the other equations are equivalent. So let's take the first one. S minus 8 plus 5 equals 17. So in our equation on the left side here, you have the expression S minus 8. So we want to isolate that so we can compare the two. That means we need to move this plus 5 to the other side. Since we're moving it across the equal sign, we're going to do the same, or the opposite to both sides. So that's minus 5, minus 5. Cancel that, and 17 minus 5 is 12. So that means that is not equivalent because we're looking for S minus 8 equals 10. So we're going to go ahead and cross that one off. And then I'm going to take this down and we'll try the next one. Okay, the next one is S minus 2 equals 10 plus 4. Okay, now this one's a little different because our expression on the left does not say S minus 8. It says S minus 2, so it's a little bit tough to compare. So what I might do is I might actually solve the original equation by adding 8 to both sides, getting S equals 18. That might make it easier for me to compare this one. So I'm going to go ahead and add the 2 to both sides so that that cancels. I get S equals 12 plus 4. Now 12 plus 4 is 16. So this is non-equivalent because our original equation had an answer of S equals 18, not 16. So I'm going to go ahead and cross that one out. Okay, here comes the next one. I'm going to leave that solution up there just in case we need it again. This one is 9 plus S minus 8 equals 19. I'm going to isolate that expression of S minus 8 because that matches what's in my original equation. But I'm going to move the 9 to the other side by subtracting it from both sides. That leaves me with S minus 8 equals 10, which is exactly the equation I'm looking for. So this third choice is equivalent. All right, let's check that last one and then we'll be done for today. Let me clear this one up. Okay, this is 4 plus S minus 8 equals 14. So again, I want to isolate that S minus 8 expression because it matches what's in on the left side of my equation. And instead, I'm going to move the 4 to the other side by subtracting it from both sides. These will cancel. I'll have S minus 8 here equals 10. And that is exactly what I'm looking for. So that is also an equivalent equation. All right, you guys, thank you so much for joining me today. I hope to see you in another video soon.